Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 9 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3208, alternating groups 2. Okay, so now let's read the problem statement first. So there is a circle of red and blue tiles. You are given an array of integers colors and an integer k. The color of the tile I is represented by colors of I. Okay, so if colors of I value is equal to 0, then that means that tile is red. Okay, and if colors of I value is 1, that simply means that tile is blue. Okay, an alternating group is a every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and last one has a different color from its left and right tiles. Okay, so see, this is first tile and there are in between some tiles and this is the last tile. Okay, so for this tile, okay, the color of this tile, it should be different than the color of this tile and the color of this tile. Okay, same way for the color of this tile, it should be different than this tile's color and this tile's color. Okay, same way for this tile's color, it should be different than this tile's color and this tile color. Okay, but for the last ones, okay, this condition is not there, right? So for this one, there is no previous tile, right? So, and same way for this one, only we have to check this tile only. Okay, we don't have to check this tile, right? In this side there is no tile. Okay, so each tile in the group except the first and last one has a different color from its left and right tiles. Okay, and the color should be alternate, right? So it's obvious, right, if the color is different from the left and right side tiles. Okay, done. Then we have to return the number of alternating groups. Okay, number of such alternating groups. Okay, note that since colors represents a circle, the first and the last tiles are considered to be next to each other. Okay, the first and last tiles are considered to be the next to each other. Okay, so this should be the case, right? There may be such case. Okay, so since colors represents a circle. Okay, so here see this example number 1. Okay, so this is colors array given to us. Okay, so we have 0 1 0 1 0 and case 3. Okay, so here see, these are in, they are in circle, right? So 0 1 2 index, 3 index and 4 index. Okay, so here see, all these indexes. Okay, so these are indexes written 0, then 1, then 2 index, then 3 index, then 4 index. Okay, so at 0, so 0 means a red color tile. Okay, a red color tile. 1 means blue color, then 0 means red color, then 1 means blue color, and then 0 means red color. Okay, so see, these are forming a circle, right? So in this case, so see, this tile color and this tile color, okay, both are same, right? And they are considered next to each other as well. Okay, here. Okay, so now here k is equal to 3, k is equal to 3, so we have to find out the groups of 3. Okay, groups of 3 we have to find out, and the color of all the tiles, alternate tiles, should be different. Okay, so if this color is red, then this color should be blue and this color should be red. Okay, or if this color is blue, then this color should be red and this color should be blue. Okay, this is what we need to find. All right, so here see, now let's start from here. Now let's start from here. Let's see this group first. Okay, this group, so 0 1 0, so this is valid, right? 0 1 and 2 index I'm considering. So see here, this is valid, so here I'm keeping count as 1. Okay, now next time if I start from here, 1 2 3, so this is also valid, right? Here see, this is also valid, so my count becomes 2 now. Then next time if I start from here, 0 1 0, okay, 2 3 4 index, so see, this is also valid, so making the count 3 here. Okay, next time you have checked 0 1 0, but you can check this one as well now, 1 starting from 1 0 and then this 0. Okay, so that simply means I'm saying to check starting from 3 4 and this, check this. Okay, this part, but here see, this color tile is red and this color is also red now, so no, it is not forming, right? Then next time I'm going to start from 0. Okay, here I'm starting from index 3 now. Next time let's start from index 4. Okay, 4 0 and 1, check these. So here this is also not valid. Okay, so in total we have total 3 alternating groups. Okay, so my output is 3 in this case, right? Clear what we need to do? Okay, right? So I'm starting from here. If you see carefully, first I'm starting from 0 index, then I'm checking this, then I'm checking from starting from 1, then I'm checking this, then I'm starting from index 2, I'm checking this complete, then I'm starting from 3, so I'm checking index 3 4 and then 0. Okay, so 3 4 and 0 I'm checking complete. Okay, then I'm starting from 4, and when I'm starting from 1, I'm checking this 4 0 and 1. Okay, so in this way I have to check all the pairs. Okay, then next time again we are not going to start from 0 1 0. Okay, we have already checked, but from 0 we can start now, 0 0 1, that we have to check. So we have to check all these possibilities, right? So see this example number 2 now. So k is 6, right? And these are the colors. Okay, so here if you start from, okay, so if you give the indexing here 0 1 2 3 4 5 and 6, so if you start from index 3 here. Okay, so see this pair 3, 4, 5, 6, 0 and 1. Okay, so in total how many tiles are there inside this? If you see 1, 2, 3, 4, 5, 6, k value 6, right? And see this is red, this is blue, red, blue, red, blue. Okay, good, we are good. Okay, so now this is done. Okay, next time you can also start from 4. Okay, let's say you start from 4, okay, instead of 3. So 4, 5, 6. So see, this is also good, right? This is also nice. So blue, red, blue, red, blue, red, right? Case 6 here, and here count 1, here count 2. So for this example number 2, output is 2. Okay, done. Okay, so see the constant size. Constant size is very large actually. Here colors dot length is 10 to the power 5. Okay, so here colors of I values, you know that 0 or 1. 0 means that it is red, and 1 means that it's blue. Okay, and colors dot length is also this k value. If you see, k value can also range from 3 to colors dot length. Okay, k value is also very large. Okay, k value is also very large, and colors length is also very large. Okay, so there is one way if I want to check this, but in that brute force I'm going to take off and square time complexity. Okay, so here I will get time limit exceed error. Okay, so in brute force what I'm doing, I am iterating over all these colors one by one. Okay, so let's say I have this 0, 1, 0, 1, 0. Okay, so what I'm doing here, I am setting this I to here. Okay, and then until k I'm running one loop. Okay, and I'm checking that all the colors are different. Okay, so if all the colors are different, okay, so then I'm making count as 1. Okay, then I'm moving I forward, and again I'm running one loop. Then again I'm moving I forward, then again I'm running it for one loop forward. Again I'm putting my I here, again I'm running the set until here. Again I'm putting I here, again I'm running until here. Okay, so until here. So see, if the colors length is 10 raised to power 6, right, or 10 raised to 5 or 10, yeah, if colors dot length is 10 raised to power 5, and if k is also 10 raised to power 5, so here see I am running how much longer here, right? 10 raised to 5 into 10 raised to 5. Okay, definitely it's going to give me time limit exceed error. Okay, so this is the simple brute force code that I execute first. Okay, so in this same thing, running one loop and setting one valid boolean variable to true, and then I'm running the j loop, okay, until k. Okay, all the k values. So j is starting from I plus 1, j is less than k plus I. Okay, because if my I is here, okay, so next time my k value, okay, I need the next 3 now. So here I'm just adding k plus I. Okay, because if my I is 0, then I'm checking the number still 3. Okay, if my I is at 1, then I'm checking the number still 4 in case of example 1 where k is 3. If my I is 2, then I'm checking until 5, right? So that is why k plus I. So here j modulus with n and j minus 1. Okay, so that is why I'm running from I plus 1. Okay, I'm checking using here j minus 1 here. Okay, j minus 1, right? So here if any color matches, okay, if alternating colors matches anywhere, then I'm setting false. Okay, and here I'm checking if it is valid, then increment count, otherwise skip it. Okay, so it's very simple code. Okay, brute force. That is why I didn't explain it while writing the code. Okay, so 531 test cases got passed here instead of 625. Okay, so we get this time limit exceed error. Okay, so here you guys are clear, right? Here why I'm writing modulus n. Okay, so see here 0, 1, 2, 3, 4. Okay, let's say you have these indexes. Okay, so now here uh, after 4, okay, let's suppose you are at 4 index. Okay, after 4 you will go to 5, but instead of 5 you want to check this 0. Okay, at 5 you will take 0. Same way at 6 you will consider this 1. Okay, right? So how you can do, right? So it's very simple now. What is the length of this complete? So length is 5. Okay, so if you are 5, then just 5 modulus with the size of array. So 5 modulus with 5 will give you 0. Same way when you are at 6, so 6 modulus with 5, it will give you 1. Okay, that simply means you are at 1 index. Same way if you are at 4, so you will do what? 4 modulus with 5, so you will get 4 only. Same way if you are at 3, 3 modulus with 5, you will get 3 only. Okay, so if you are moving further, but we don't have 5 index, so I'm taking 5 modulus 5. Okay, so here 5 modulus 5, so colors of 0 I'm checking again with previous, that is let's suppose, okay, let's suppose my j is a 5. Okay, so here 5 modulus with 5, so you are checking colors of 0, colors of 0 with and here 5 minus 1, 4, 4 modulus with 5, 4 modulus with 5, 4, 4. Okay, so you are checking this 4 and 0. Okay, so that's the reason. Okay, modulus 7. Now let's come to the original approach, okay, that we are going to use to solve this problem. Okay, and I will write the solution of that approach in just 5-6 lines. Okay, so it's not very complex. So here what we are dealing with, we are dealing with windows only. That is nothing but a sliding window approach. Okay, so we have to simply use two passes here. Okay, we are going to use the left pointer and right pointer. Okay, so let me explain you the sliding window approach using this bigger example. Okay, example number 2. So we have 0 1, then 0 0 1 0 1. Okay, 0 1, then we have 0 0, then we have 1, then we have 0, then 1. Okay, so right, let me compare 0 1, 2 zeros, 1 0 1. Okay, case 6, k is equal to 6. All right, so now let's understand this problem. Okay, so here let me just give the indexing 0 1 2 3 4 5 6. Okay, so this is your array. All right, so now here in the sliding window approach, what you are going to do, you are going to place your left pointer here. Okay, place your left pointer here, and now you have to move your right. Okay, so here first let's say your right is here. Okay, let's say your right is here. Okay, this is where your right. So you are going to compare this value with this value. Both are different. Okay, if both are different, you are going to move this r here. Okay, then you are going to compare this value with this value. Okay, both are different. Okay, previous value, that is why I'm starting r from 1. Okay, so we are checking with previous value. Okay, so both are different, so I'm going to move my r forward. Now my r is going to reach here. Okay, my r reaches here. All right, so now in this case, if you see this value and this value both are matching. Okay, so that simply means that I need k is equal to 6 size, this size window, but in this window it is not possible, right? Because both these tiles are having same color. So what I'm going to do, I'm going to reset. Okay, I'm going to reset this left. Okay, so I'm going to simply move this left to this position. Okay, so now my window is going to start from here. Okay, because I don't need these two in my window, right? Because if I include these two, definitely I will not get the perfect answer. So my L is going to move to this R. Okay, so here let me erase this. Okay, so now my R and L both are at this. Again, my R is going to move forward again. Okay, so here my R is going to move forward. So my R reaches here. Then I will check these two. Okay, good, done. Then my R is going to move here. Okay, I'm going to check these two. Okay, good. Then my R is going to move forward. Then again, it's both are good. Okay, so right now, if you see, my R is at this position. Okay, this position. Now after that, this is a circular array. So definitely my R is going to move to this position again. Okay, but this is I'm saying, right, that I'm going to compare this with this. Okay, but my R is going to move forward only, right? Here I will just do the modulus operation. Okay, so here what I'm going to do now, see here, my R is going to move to this index. Okay, which is nothing but 7. Okay, but I'm doing the modulus. Okay, so I will check this with the 0. Okay, so my R will be here only, but my R value is going to be 7. Okay, my R value is going to 7, but I'm comparing this element. Okay, done. I'm comparing this element with this element. Okay, now next time my R value is going to be 8. R value is going to be 8, and if you do 8 modulus with the size of this array, which is 7, okay, so you will get 1. So my R will be here. Okay, so I am going to compare these two, right? Okay, now here this is done. So here if you see, your L is here. Okay, left is here, 0 1 0 1. Okay, 4 elements here, and here you have covered 2 elements, 0 and 1. Okay, so your R is here now. R is here. That simply means R is 8, but I'm right. How I'm comparing 8 modulus with side. 8 modulus 7 is 1. Okay, so I'm comparing these two. Okay, so first my R compares these two, then my R compares these two, then my R compares these two, then my R compares this with this, then my R compares this with this. Okay, so now here we have 6 elements. So here in the sliding window there is simple formula na. If you subtract R minus L plus 1, so if the value, this value, if it becomes equal to K, so here right now my R is 8, my L is at 3, and plus 1 is equal to 6, right? 8 minus 3 is 5, 5 plus 1 6. So values are matching. So that simply means that I get one value, I get one window, right? So in this window, so this window is a perfect alternating group, right? So I have to make the count as 1, right? In this case, so my R minus L plus 1, it becomes equal to K. So now my count will become 1. Okay, so this is perfect window. So now for the next part, what I'm going to do, I'm going to increment this L now. Okay, I'm going to check the next window. So here my L is going to move here. Okay, next time. Okay, now after that my R is going to move to 8 or 9. Okay, R is going to move to 9 here. So 9 modulus with 7, I will get 2. So I'm now, what is the window I'm checking? So here let me just remove this. Okay, let me just remove this. Okay, so now my R is moving here, right? I'm saying. So now here in this part, my L is starting from here, 1 0 1 3 elements here. Now my R also moved to 7, 8 and 9. So that simply means that these 3 also I've included. Okay, so in this also my R already compared this with this. My R already compared this one. My R already compared this one with this one. My R already compared this one with this one. Now this time my R compared this with this one. Okay, and my window is moved one step forward, right? So here in this window also you see R minus L plus 1. So R is at 9. Okay, my R, I am representing it here, but actual value of R is 9 here. Okay, so 9 minus L is at 4 plus 1 for 5 minus 5 plus 1 6. So it is equal to k, right? So if it is equal to k, then I found one more group, right? So 3 and 4. So if you see example here, starting from 3 and 4, we have found one group. Okay, so this is what we need to do. Okay, simple. In one window only I'm checking first this window, then this window, then next window, then next window. Okay, like this. Okay, this is clear, right? How we are checking the window and how we are moving my R and L. Okay, so now one more thing here. Until when we have to do this? Okay, where we need to stop? Okay, so here if you see this example, okay, if you see this, let me just explain this simple example here. So see this example, we have 0 1 0 1 0. Okay, so we have k is equal to 3 size window. Okay, 3 size window always, right? So here I am comparing, first I am taking this window. Okay, see, listen carefully. First I am taking this window. Okay, good. Then I am taking this window. Okay, then I am taking this window. Then I am taking this window. Okay, that simply means one more element here. Then from here I am taking one more window. That simply means one more element here. Okay, then after that we don't need to check now, because first you are starting from here, then 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 again you are going to start from here. No, because we have already checked this window now, so we have to stop until here. Okay, so here see how many elements until where until how many elements that we are checking here in this range. Okay, we are checking, we are considering these 5 and these 2 more, because I need this window also now. So here I need this 0 again. Okay, I need this 1 again to check this window. Okay, so here what is the size then? So here total size here of this original color array is 5. Okay, that simply means my n is 5. Okay, my k is 3 in this case. So I can simply say now that if I do n plus k minus 1, so until here I have to run the loop. Okay, so n is nothing but 5. 5 plus 3 is 8. 8 minus 1 is 7. Okay, so if you give the indexing here 0 1 2 3 4 5 6, okay, until 6, so less than 7. So this until here I have to run the loop. Okay, my right loop. Okay, so now let's write the code. Okay, and I will explain just 4 5 lines, nothing as much. Okay, so this problem is actually very simple. Okay, so here first of all you have to just create one count result. Okay, we have to store the result somewhere. Okay, so create one variable count and set it to 0. Okay, let me just increase the size. So count is equal to 0. All right, and now after that just calculate the number of the array. Okay, the colors dot length. Done. And then take one left and set it to 0, and then you have to run your right loop. Okay, so int right and start it from 1. Okay, I will do right minus 1. Okay, so here right here, and my right will go until right should be less than n minus k plus 1. Okay, so this number of elements I need. Okay, and here right plus plus. Okay, so I hope that you guys clear n minus k plus 1. Okay, n minus k plus 1. So if you see this example, okay, so see this here. Okay, so if you see this, so here also total size of the original array is nothing but 7, right? 1 2 3 4 5 6 7. Okay, so 7 plus 6 minus 1, so 7 plus 6 is 13. Okay, 13 minus 1 12. So until 12 you have to check. Okay, 10 11 12 also required. Okay, to check further windows. Okay, so when you are going to start from 5, okay, then you are going to start from 6. Okay, all this stuff, right? So all these things you have to check, right? Okay, so this is very important, right? This step 7 is the size, right? 0 1. Okay, here see 7 is the size. 7 plus 6 minus 1 you have to do, you will get 12. Okay, so less than 12. So here less than 12, it should be less than 12. Okay, so until here. So right now when you start from 4, if you see here, when you start from 4 you have covered until r is 9. Okay, when you are going to start from 5 you will cover 10, and when you are going to start from 6 you are going to cover 11. Okay, so this is less than 12. Okay, so here no 12, less than 12, right? So this is the line. And here if inside this, if here you have to write colors, okay, and here write -1 because I'm running the loop from starting from 1. So here write -1 and do the modulus with them. You already know why we are doing this. Okay, so if write -1, okay, let's write it like this now. Write -1 and here inside this do the modulus with n. Okay, if it is equal to, here just simply copy this, paste it here, here just write right. Okay, colors of right, and here modulus with n. All right, so if they are matching, then I told you now, if they are matching, then we have to reset window if alternation breaks. Okay, so here I'm just going to set left is equal to right. Okay, this is what we did, right? Here both are same, so I simply jump my L to this position. Okay, here, right, in the starting we did this. Okay, because these both are matching now, so I don't need this in my window, so I directly jump my L here to my right. Okay, so left is good, right? And here this window size right minus left plus 1. Okay, so this is always going to give me the window size. Okay, so if right minus left plus 1, okay, is equal to k, that simply means that this is perfect window. So in that case, increment the count and move the left part of window. Okay, so we have to check the next slide. Okay, so we are just writing the window forward, done. And now here just return count, that's it. So simple, return count. Okay, now let's run the code and see if there are any code issues. So yes, there are some issues, so let's see and we will try to fix that. So here right is less than n, it should be n plus k minus 1. My mistake, n plus k minus 1. Okay, so see here, I told you n plus k minus 1 only here, but mistakenly we write a wrong thing. Okay, so here see n plus k minus 1. Okay, here n plus k minus 1. So yeah, n plus k minus 1. Now let's run it. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.